In this video, I am going to explain what are the pattern design considerations. So the pattern design considerations, first of all, what is a pattern? So importance in casting, role in determining quality and cost. Based on that, we consider the design points. So what is a pattern? It is a replica of object which we want to produce as a casting. So importance in casting. So the bulk materials products we want to produce using the casting process, it's very the farmer and the best manufacturing process to obtain different use castings. So role in determining quality and cost. So by taking the design considerations, it will affect the what is the quality and what is the cost of the product we are going to produce. So what are the main objectives of pattern design? The main objective of the pattern design is accurate mold cavity and easy of molding and casting, durability and reusability. So these are the main objectives. And what factors affecting pattern design? So the types of casting process, that is one important factor which affect the pattern design, and complexity of component we are going to produce, and production volume, how many number of quantity of products we are going to produce by using the same pattern, and dimensional accuracy. So what accuracy we are affecting. So these are the points we will consider as factors before designing the pattern. So what are the different allowances in the pattern design? The shrinkage allowance, draft allowance, machining allowance, and distortion allowance. So wrapping allowance also sometimes we consider while deciding the dimensions of the pattern. Now let us see the briefly one by one. What is the shrinkage allowance? So the allowance to compensate for metal contraction during the solidification and cooling process. So to compensate, the pattern used to make the mold must be made slightly larger than the final desired casting sizes. So the extra dimension added to the pattern is called the shrinkage allowance. For outer dimensions you can add, for inner dimensions you can subtract this allowance so that you can obtain the final size of the pattern. So the allowance depends on the type of metal or alloy, the length of the casting. So based on the length and metal, you can choose the allowance. Different metals, they're having the different allowances. Let us see that in this diagram. Now this is a shrinkage of cast. Okay, finally the casted area of the material that shows the dotted line. After solidification, it comes to the this solid line shape. So this difference of this amount is the allowance. That allowance is known as a shrinkage allowance. So shrinkage allowance is expressed either as a percentage or as a shrinkage rate. Now let us see the different materials. What are the shrinkage allowances are given below. So for a grey cast iron, shrinkage rate is 10 mm per meter length, or in terms of percentage it's a 1%. And for steel material it's 20 mm per meter length and 2%. For brass 15 mm per meter length 1.5%. Aluminum 13 mm per meter or 1.3%. So either you can take in terms of the shrinkage rate or in terms of the percentage to calculate the final dimensions of the pattern. So remember, these are the few material likes, each and every material they're having the their own shrinkage allowance, shrinkage rate. So correspondingly those values you can consider while determining the final dimensions of the pattern. So what is the basic formula used to find out the shrinkage allowance? For example, L is equal to required dimension of casting, that is the final size, and S is the shrinkage rate or shrinkage allowance. Then the pattern dimension you can obtain L into 1 plus S. So where S is you take as a shrinkage rate, or if you take in percentage divided by 100. Okay. So the simple example so that you can clear about the how you can add the allowances, you need to produce a steel casting of length 500 mm. Shrinkage rate for steel is equal to 2%. So the shrinkage allowance is equal to L into S 10 mm. So the pattern length is 500 into 10 510 mm. So make the pattern length 510 mm to get a final casting length of 500 mm after shrinkage. So let us how allowances is considered for the dimension type. So the for external dimensions, the length, width, and height added to the pattern. For internal dimensions like holes, slots, recesses, subtract from the pattern. So you need to cast a hole of diameter 100 mm in an aluminum casting. The shrinkage rate for aluminum is equal to 1.3%. Then you can find out the shrinkage allowance. So the shrinkage allowance is 1.3 mm. So pattern dimension for hole, since it is an internal dimension, so we subtract the shrinkage allowance so that the pattern hole diameter is obtained 100 minus 1.3, 98.7 mm is the diameter of the hole to be prepared in a casting. Next, coming to the draft allowance. So draft allowance is the slight taper provided on the vertical surfaces of a pattern to facilitate its easy removal from the sand mold without damaging the mold cavity. So why it is needed? So when a pattern is removed from the mold, the friction between the pattern and the sand can damage the mold edges. So once we are providing a taper, it reduces this friction and ensuring the mold cavity retains its intended shape and dimensions without damaging while removing the pattern. Now here look at this diagram, the draft allowance, the taper allowances, the internal surfaces and external surfaces. For external surfaces, we keep as it is the main part dimension that will keep at the bottom part, and the top part we are providing this taper allowance. Whereas for internal recesses, the top part will keep as it is, and internal part will reduce this dimension. Okay, like this the taper will provide on the only it will provide on the vertical surfaces. So there is no necessity of providing the bottom surface and draft surface. So what are the different typical values we consider for external taper and internal taper? For external surfaces, around 1 degrees to 2 degrees, sometimes up to 3 degrees for complicated shapes we will consider. Whereas for internal surfaces like holes and recesses, usually more about 2 degrees to 3 degrees, since these surfaces are harder to withdraw compared to the external surfaces. So now let us see one problem on the draft allowance. A wooden pattern of rectangular block has to be prepared for sand casting. The size of casting required is 100 mm height, 60 mm by 40 mm. The draft allowance to be provided 2 degrees on all the vertical surfaces. Then you can find out what are the top dimensions of the pattern if draft is applied only along the height 100 mm. So height is 100 mm and draft angle is given 2 degrees, and you can find out the draft angle. So the draft value, the dimension is obtained height into tan of that draft angle. So 100 into tan 2 degrees, it's approximately 3.49 mm. So since the draft makes the top larger for external surface, so increase on each side. So on both sides we are going to provide the taper. So each side you can increase 3.49 mm. So the total increase in width is twice of this value, that is 7 mm. So the bottom width, now you can find out the final dimensions. For bottom width is 60 mm, whereas the top width is 60 plus 7, 67 mm. And coming to the other dimension, 40 mm is the bottom and top length is 40 plus 7, 47 mm. So the top side is 67 by 47, bottom side is 60 by 40. Now let us see if we consider the internal the dimensions, how we can calculate the draft elements. Based on that, this problem is given. A cylindrical pattern of height 150 mm and base diameter 80 mm is to be prepared. Provide a draft allowance of 1.5 degrees on external vertical surface. Calculate the diameter at the top of the pattern. The solution is draft height into tan of that angle 1.5 degrees. You can obtain 3.93 mm. So increase on the radius 3.93 mm. Diameter increases by 7.86 mm. So the top diameter you can increase 80 plus 7.86, 87.9 mm. So I hope everyone understand what are the main design considerations for this. In this video it's explained.